Yes, good morning, everybody. Let's move on with respect to the revision considered in the case of this robotics subject. Initially, moving on with respect to the unit number 5 and 6, and later on, I will be discussing with respect to unit number 4. These are the concepts which are related in the theoretical part, and unit number 4 related to the mathematical relations. In the unit number 5, trajectory planning and its consequences will be discussing in the today's class. Initially, with respect to the unit number 5, we are having the general considerations to discuss regarding the path description. Nothing but the robot that is being traveling in a prescribed motion, or else the trace that is being taking place involves n number of cities or n number of transformations. Because globally, if you have been considering the 3 degrees of freedom, almost all the links and overall robot need to be change its position from initial place to the second place and from the second place to the third place. Either the commencement of activity may be in the form of this rotational statistics or revolutionary statistics, or else the transformations, nothing but the translations, prismatic movements in either of the 6 degrees of freedom. Either it may be of Cartesian coordinate systems, spherical coordinate systems, cylindrical coordinate motions, or else in the articulated system, as we have been discussed in the second unit. And in the today's class, we'll be discussing regarding the trajectory planning. Going on to the trajectory planning, initially the planner exists some specified points indeed to actuate the different links and different elements which are interlinked to the robotic device, the main skeleton of the robot. And indeed, to commence the activity from this trajectory, the commencement of this trajectory, almost all the elements that are assembled to the robot need to be function simultaneously. So with that, the movements will be getting captured. As we have been discussed that the movements related towards the prismatic, revolutionary, rotatory, etc. etc. The combination of both the rotation and its prismatic, or else the revolution and rotation, and even the simultaneous transformations. That is sliding actions towards the positive x and negative x, or a positive y or negative y, and maybe in the positive z or a negative z axis also. Coming to the major functionalities of this robotic trajectory planner, the trajectory planner, which is being programmed in the sequence of steps, series of steps in the algorithm basis, and the program has to be interlinked with respect to the controller and then to the both internal and external devices which are having interrelated with respect to the trajectory planning system. And this trajectory planning system will be submerged with respect to a controller, and hence controller will take care of the overall elements, either it may be of an internally existing elements or else the externally consisting elements. So the elements, in the sense of feedback devices which trap the outcome towards the trajectory planner, that whether the given instructions in the form of an algorithm or a sequence of steps in the program or being executing or not. So that relates with respect to the trajectory plan here. So initially, the task planner, nothing but it program instructions that will be given to the trajectory planner. And next, this planner will execute the sequence of steps given to the system in the form of steps. And this controller will take care of necessary processing actions by different elements which are assembled in the entire robotic system, and that will guide the robot. And here the robot relates towards the combination or assembly order of different elements in a single statutory. And internal sensors, so here the internal sensors specifies that whether the instruction that has been given in the form of a program of steps from the trajectory planner has been commencing by this robot or not. That will be given as a feedback device to the trajectory planner. And hence, the actions of the robot will be specified in an enclosed system of the environment or else in the wide and or else open system environment. So that environment may be of an closed system or else the open system. So open system in the sense nothing but it's having unlimited boundary conditions. So in the closed system in the sense the boundary conditions will be specified that the robot should be actuated or else the commencement of motions should be in a particular limitations of floor space, and that will be commenting. And whether those actions are in the environmental familiar conditions or not will be specified with respect to the external sensors, and that external sensors will give the entire that signals to the trajectory planner whether the execution is being taken place within the limitations as per the directions given in the form of an instructions or not. And the external sensors will be interlinked with respect to the task planner that furtherly if there are deviating with respect to the environmental conditions or else the boundary conditions in the space that will be modulated and that to be edited for the feasible operations that will be calling the movements in entire three-dimensional spaces or else the global coordinate systems has to be performed in a particular conditions of operations for its better movements. And that we are calling as the work that is being done by the end effector, which is being occupied its space in the universe. That is nothing but the space that is being operating by a particular robot within the environmental conditions. That is nothing but the work volume, the space that is being occupied by the particular robot, work volume. And here, the robotic actions which are being progressed in the form of a sequence will be energized with respect to a particular modes. And hence, those modes, we are having four different kinds of modes. First one is an mechanical mode of energization, nothing but by utilization of these levers, pedal-based systems, external application of the force, etc. will guide the trajectory planner indeed to schedule the sequence of steps. And hence this trajectory planner will furtherly actuates in a proper directory which causes the reference or final values. Here the reference values specifies that discrete or continuous variables of the robot controller, nothing but the values which are existing as an default conditions will verify furtherly by this trajectory planner whether by the planner we are getting a feasible values or not. There is an interrelating values. So within the allowable limitations the output values are being achieved or so in this way the trajectory will be getting planned. For this let us consider an example, considering a tram car which is being automatically monitored by the systemic device, nothing but a robotic device. When it has been programmed, it has to move from station 1 to the station 2 exactly it will be having a track that will be commonly specified its route map, and that particular tram car has to be moved from station 1 to the station 2, that's having a 5 kilometers of distance in inter between the station 1 and station 2, that has to be completed its movement within 2 minutes of time. That is nothing but 60 plus 60, that is 120 seconds of time. So the time will be indicated and constant time will be fed to the program, and hence the program will guide for further actions of moving this tram from source 1 to the next destination 1. And the control, if at all intermittently it is being the track is doesn't have any intermittent calamities. So here the intermittent calamities leads to the formation of the obstacles that we will be having in clear here, the obstacles in the syllabus point of view. So obstacles. So obstacles is nothing but in the roadways as we are casually moving by our automobiles, either it may be of a two-wheeler or else the four-wheeler. When the speed breaker has been arranged, suddenly the movement or else the speed will be gradually decreasing, and next shifting of the gears will be commenced, and later on depending upon the speed variation gear shifting will be maintained, and upon accelerating and after bypassing that particular speed breaker, again the speed will be maintained as per its statutory. So here the trajectory planner is nothing but a person who is driving the vehicle, that he used to monitor over the speed and brake, shifting of the gears, the clutch movement, and balancing of the vehicle, etc. actions will be performed by that particular person. But here in the case of the robotics, will be having a certain standard procedure for guiding the robots. And hence these robots will store that particular instructions in the form of a program, and what are the actions need to be performed. I think that here the brain will take in the manual mode, the brain will take care of creating the specified necessary actions, and those will be forwarded for necessary actions. But whatever the brain is being taking actions, but spontaneous decisions, nothing but spontaneous decisions. Here in the industrial characterizations or in the robotics activation elements, the robotics for the robotics will be giving a programming. But a programming is a standard one or else it is a rigid one, that only the instructions that has been given to the robot will be getting performed, but not as per the situational basis. It doesn't actuate as per the situational basis or else in the series of accordance as per the environmental conditions are being maintained. ఎన్విరాన్మెంటల్ కండిషన్స్ లో మనకి ఒకవేళ ఎక్కువగా టెంపరేచర్ ఉన్నా లేదంటే ఫ్లడ్ వచ్చేసేసి వచ్చినా లేదంటే ట్రాక్ డెస్ట్రాయ్ అయినా కానీ ట్రైన్ మాత్రం ఆగదు, ట్రామ్ కార్ మాత్రం ఆగదు. అదే మాన్యువల్ మోడ్ లో అయితేనేమో జనరల్లీ విల్ బి టేకింగ్ ది విల్ బి విజువలైజింగ్, అండ్ నెక్స్ట్ ఫర్ దట్ necessary actions, spontaneous actions will be getting taken place. Simultaneously, for that inconvenience existing in the industrial robotics, sensors has been came into the place, and hence these sensors will capture the track initially. There is a displacement sensors, how far it has been moved, and what speed it has to be maintained. If the speed has been furtherly increasing, depending upon the distance to be covered, the speed will be gradually increasing by the sensors. There is a closed loop control system, and that will give sensors will give the feedback alignment to the controller. Based upon that, the controller will execute the series of instructions by the processor randomly for commencement of the activity in a better way. And here, in the case of industrial robots, nothing but manufacturing will be getting existed. Manufacturing of different things. So those things has to be increased in its production, nothing but quantity should be increased, and hence even by increasing or maintaining a particular quality. So that is the major source here. So let's have a procedure for the industrial robots. Defining the Cartesian pose points. So here Cartesian pose points in the sense XYZ axis of movements by the robotics links. So link 1, link 2, link 3 as we have been specified in the robotic system until the operate maintains. It will be getting extended furtherly. Next, the program and velocity between these points, nothing but just as we have discussed from point 1 to the point 2, how far the distance has to be moved, and random actions need to be performed from 0 to 100% of maximum system value. Nothing but efficiency level should not be increased. As we have been discussed now, efficiency in the quality of the product will be decreasing. If the quality of the product decrease, demand for the product will be very much less in the marketing field. So for increasing the demand, the quality should be maintained further as it is, as per the system mark or the company mark. Next, the linear interpolation in the joint space between points sampled from the built trajectory. Hence, the trajectory is being given in the form of an series of steps in the form of programming, and for that commencement of those instructions, that will be entire the program of instructions will be converting in the mechanical actions, and those actions will be getting reflected in the form of the actions that are being done by the actuators that are being assembled in the robot. That's one. So we'll be looking after the some of the examples here. The additional features that are being existing in the industrial robots, that is nothing but overfly. So here overfly in the sense bypassing the situation, nothing but from A, B, C, D. That is, for example, we are having 4 different stations. So A దగ్గర వచ్చేసరికి టర్నింగ్ ఆపరేషన్ జరుగుతుంది, B దగ్గర వచ్చేసరికి మిల్లింగ్ ఆపరేషన్, C దగ్గర డ్రిల్లింగ్ ఆపరేషన్స్, D దగ్గర వచ్చేసరికి అసెంబ్లీ కండిషన్స్. But after commencing here overflow in the sense, after commencing of the particular process in the A, without performing B, it has to be proceeded towards the C. And after completing the process in the C, it has to be moved to D. After that, not to the A, but it has to be shifted to the B, nothing but bypassing the A and next to the B. So for that actions, there's an additional features as per the design criteria, because here the machineries indeed to progress a particular process, machineries should not be kept in an ideal position or else in the halting conditions. And even these machineries will not be getting transplanted from one place to the another place easily, because those will be having heavy weight, and once if you have been fixed it, the operating conditions also will be getting varied if you have been changed furtherly. So for that convenience, only the work parts will be getting deferred, but that work part, the sequence of process may be deferred depending upon the design criteria. First milling has to be performed, later on drilling has to be performed, or later on the reaming process need to be performed likewise. So for our convenience, will be transferring by bypassing the one process as per the requirement. Next one, sensor driven stop. So this is one of the additional feature that is being utilizing in the robots. Nothing but the complete actions in the form of a feedback will be getting here. And furtherly, if the sensor doesn't support the satisfied conditions to the default conditions, then for the further commencement of the operation, the guidance will not be getting taken place. Nothing but output will not be getting satisfied until and unless the default conditions has been coincided with respect to the sensor when it has been tracing with respect to the feedback. Feedback కనుక మనకి అవుట్పుట్ నుంచి ఇన్స్పెక్షన్ ప్రాసెస్లో చూసినప్పుడు డిఫాల్ట్ కండిషన్స్కి కనుక మ్యాచ్ కాకపోతే అవుట్పుట్ జనరేట్ కాదు. సో జనరేట్ కానప్పుడు ఆటోమేటికల్లీ ది సెన్సార్ విల్ నాట్ బి యాక్టింగ్ allowing the output to be delivered. So advanced conditions so that sensor driven stop plays a major important role that will be getting instructions from the controller to stop the inspection technique, and that will be guided by manual process. Next one, circular path through 3 points, nothing but by operating the circular alignment only by 3 different points, and means looking after the drawbacks. These are the additional benefits and general benefits as we have discussed till now. And coming to the drawbacks, semi-manual programming, that is nothing but first generation programming languages are limited in its operation because they doesn't calculate furtherly the actions related towards the um, advanced conditions of the robot, and limited visualization of motion. Having the limited visualization. So limited visualization in the sense nothing but indeed to enhance the conditions based upon the spontaneous actions, it will not have the particular broad visualization. Hence, whatever the program that has been given, only that will be verified and commenced the, in the form of the actions. The mathematical formulation of trajectories is very much useful and needful for calculating the actuation positions. For example, this is the robot actuating positions in the sense this is the basic frame, this is the link 1 and having the joint rotary joint, and hence this is the link 2 having and the rotary joint here, and this is the link 3 and the rotary joint, and this is the link 4 and the rotary joint, and this is the link, and hence this is the base alignment, and point to point coordinate system with an intermediate points. So by bypassing the system, point to point actions will be getting maintained by X, Y, and Z. So straight lines that is being commencing by the robot. So straight lines is nothing but the actions or contraction positions that need to be maintained from the initial point to the positive y-axis to a 10 points or 20 points, and next to the simultaneously the system that is being generating the curvilinear positions. So for in the Cartesian coordinate system that tends to move the straight line motion, that is x, y, and z, either in positive or else the negative axis, leads to an straight line motions in its further actions. In the curvilinear, for the curvilinear positions, the revolution or the rotations need to be considered. And for that, the almost all the articulated kind of robot has been scheduled here. This articulated robot will traverse or generate the interpolation, that is nothing but circular interpolation, or is the circular motions related towards the given dimensional accuracies. There is nothing but need to trace out from the origin point with respect to a particular radius that will be getting drawn by the end effector as shown in the diagram. This is the end effector which holds the let us say this marker, and marker will trace a particular trace, that is circular interpolation. So the circular interpolation relates towards the by the rotatory joints or the revolutory joints. And hence here the same traverse which is having the allowable moments of 6 degrees of freedom, 6 degrees of freedom will traverse in the form of a straight line. And hence this is called the Cartesian path in the first pictorial representation. And second one, it is called the Bezier curves that are being generated by the robots. Next one, the joint and Cartesian trajectories. Here, assignment of a task, nothing but giving a task for the robot. Arm reconfigurations between two inverse kinematic solutions associated to the given and other force. Nothing but the Reconfiguration in the sense changing of its program. Instead of traveling towards the kinematic actions, the inverse kinematics has to be progressed. So we all aware of this kinematics of a robot and inverse kinematics of a robot. Nothing but the actions that are being commenced by a robot and forward alignment. Nothing but the extension activity or in the clockwise movement of a robot leads to as an kinematic solutions. And next, the inverse kinematics in the sense nothing but back movement of the robot, nothing but here the link 1 extended, link 2 extended, link 3 also extended, 4 extended. So that is forward kinematics. Reverse kinematics indeed to commence the same position. So this is the extension characterization. So this angle extended and next second one it is extended and this one extended. So this is the extended position of the robot kinematics and this is an inverse kinematics. From the extended position, the initial at the base of the joint, this joint is being commencing here. So this joint movement has been taken place. So the coordinate axis of this particular joint will be transplanted to this particular joint. So this is the characterization, or in other words, changing from its initial position and the final configuration. Or else the extended conditions also replaces from the, if this is the extended conditions, will be transferred from the original position towards the final position. So this is the transplantation conditions, or else the movement or shifting of the joints. Nominally, we will be calling shifting of the joints. So that we will be calling the extension and contraction positions. So the counter names for that is it is forward kinematics and the inverse kinematics. So kinematics is nothing but the movements. So indeed to perform the trajectory, particular trajectory, kinematics and the inverse kinematics plays a major role here. So considering this, the green color indication as an initial position and the blue color indication as a final position. Same Cartesian force, the motion cannot be really specified in the Cartesian space because shiftings will be getting commenced here, or nothing but the link positions x comma y comma z values will be getting deferred from the initial position to the final position. So in what way? If here we have to analyze that, for example, this is the joint number 1, this is the joint number 1, this is the joint number 2, this is the joint number 3, and this is the joint number 4. If the joint number 3 need to be your joint 1, 2, and this 3. The joint number 3 need to be changed position from one place to the other place shifting. It leads to and changes in the joint number 2, 1, and next even the joint number 4 also as well. Because this joint number 3 is directly depending upon this joint number 2. Joint number 2 is depending upon the joint number 1. And this indeed to shift here based upon this joint from here to this, the inclination has to be forced. And here there is another inverse here also. There's nothing but the orientation happening in the joint number 1. And if there is any further movement in the joint number 4, and simultaneously here also the theta will be getting variations. So here the phi value, revolution concept of phi value will be getting changed. Here the theta will be getting changed. Here also the theta will be getting changed. And here also the theta will be getting changed. So theta 1 plus theta 2 will be getting changes. And depending upon this theta 1 and theta 2, theta 3 will be also changed. Alright, so this is the strategy that we have been already discussed in the unit number 3. That unit, and we have solved the n number of problems also in the classwork itself. Here we are considering n is equal to m is equal to 6, nothing but 6 degrees of freedom. So to perform this task, the robot should leave its end effector pose and then return it to it. Nothing but have to inculcate end effector because only this particular joint has been shifted and there is no any imposing on this particular end effector. Hence the end effector will be neglected here because there is no any further changes in the end effector. And another skew symmetric matrix or skew motions or self transformating motions or shifting will be commencing in the case of this joints. So indeed, to increase the theta here, it will be commencing. And next, the shifting of x comma y comma z values will be deferred here in the joint number 3. And hence, these manipulators, when m is equal to n, the execution of the task will require to pass is just single configuration, nothing but when m is equal to n, nothing but the performances or the degrees of freedom that allows the conditions for the movement of the element which is having a rotatory joint should allow n number of rotations with respect to the m elements. So then we'll be having a clear cut intuition. That should be noted. So for that, if this has been performed, then the joint and cartesian trajectories can be performed. So joint is nothing but different skew motions will be erased, and next different curvilinear positions will be allayed, circular motions will be allayed, and even the linear motions also will be getting allayed. A single phase trajectory, the single phase trajectory in the sense only the joint space conditions, because there will not be any intermittence between the source point to the destination point. I think, but there will not be any stops clearly specified in the picture also. So from the task to trajectory, come to the conditions of task to the trajectory. So trajectory, geometrical path, and the timing law need to be specified to the robot. So how much time indeed to occupy, how much time will be preferred, that need to be analyzed by the task planner for providing the movement from A point to the B point. So let the path can be specified. So path be P of T, rules P of Yes. So that it will be changing its end effector position depending upon the joint's position variation also. Here joint number 1, joint number 2. So the moments changing in the joint number 1 and 2 leads to the movement of the end effector. This end effector is nothing but the position of towards the x, comma y, comma z alignments. And later analyzes the time schedules for its movement. This is the trajectory which is being generated with respect to the geometrical path. So geometrical path here specifies the x comma y comma z coordinate values that the system will transfer from one place to the another place. Nothing but has to move from the source point A to the destination point B. And for that, nominal calculations need to be get generated, and how much time it will be getting preferred, the time sense or time law will be getting ordinated here. So trajectory planning sequence. First one, the sequence of force points. Indeed, the sequence of force points in the Cartesian space. The conditions of interpolations should be satisfied, and for the that is also the interpolation in Cartesian space should be satisfied, and for that Cartesian geometrical path, nothing but the position and orientation need to be analyzed. Conditioning, the second condition, that is sequence of nodes in joint space, nothing but interpolation in the joint space that leads towards the geometrical path in the joint space. So here extension in the sense, we all aware that from the cylinder and piston movements, it will be getting extended towards the positive until the end position has been get hit by the striking element, and next coming back to its position again. So here in the case of these knots or interpolation movements with respect to the joint, the theta orientation will be varied, or else the skew motions or nothing but the cylindrical motions need to be analyzed. That is nothing but theta and pi will be characterized in the point number 2, and point number 1 Cartesian systems, nothing but the positive x or negative x, simultaneously positive y or negative y, simultaneously positive z or negative z. So these are the constraints that need to be analyzed, or considering points or analytic inversions need to be taken place for trajectory planning. And beyond that, additionally have to be considered some of the issues such as obstacle avoidance, just as we have been discussed previously that if any of the additional track has been specified perfectly, there is no any issue. If the track has been disconnected simultaneously, that need to be getting stopping conditions. So for that, the sensors plays a major important role. Will give the signal feedback to the controller, and controller will stop the execution of the program right at that particular point. So it stops the entire process commencement in the form of actions. And next, the second thing it is online or offline computational loads. So if there is any further loads that has been commencing, when the particular process is going on, so that additional load cannot be bared with a robot because the trace will be involving with respect to the specific weights of the links and the joints that we are being placing. And if furtherly has been loaded, the time variations or time gaps will be varying. And hence the sequence of operation has to be analyzed, right? So considering one of the example that considering Cartesian points, nothing but point number A, B, and C, that is traveling from point A to point B is P of ES, and traveling time from the B to C with respect, and these are the joint spaces. In the joint spaces initiates the local spots in joint spaces. Considering point A and next to the point B carries with respect to the lambda value or wavelength that has been specified from point 1 to point 8 lambda of course with respect to the q1 mode, q1 lambda, and from the point number 2 which is q2 lambda, and for the commencement of overall strategies A, B, and C is an q3 lambda. So lambda here specifies the wavelength fluctuations of the graphical representation that is being performed by this robotic device. So trajectory classifications, how in how many ways the trajectory has been classified. First one it is space of definition, nothing but Cartesian and joint. So Cartesian in the sense moving into a particular section, straight line motions. So these straight line motions will be getting analyzed only by this Cartesian coordinate system. So Cartesian coordinate systems involves only the prismatic joints. So prismatic joints in the sense either positive x or negative x, or either y in both positive and negative, z in both positive and negative. Task type. So what are the task types will be getting commenced in the space of the Cartesian system. So that is nothing but point to point, multiple points, nodes as we have been seen in the previous graphical representation, and even the continuous concatenatives. Next, path geometry. It can be in a rectangular motion or polynomials or else the exponentials or cycloids or even the triangles also. So the timing law, bang bang in accelerations because it will be getting shifting, and trapezoidal in velocity and polynomial. The coordinated or interdependent motion of all the joints or Cartesian components that is involving with respect to starting and ending at the same instance. That is whether what we are utilizing as a source point, again after connecting the all points, it has to be come back to the original back position again, or it is an timed independently motions which are being commencing by the joining of these particular points. That is independently related with respect to the time, and as per the displacement of the joints which are existing in the robot will be analyzed. So that is called the joint space, and it will leads to an counter positions or circle positions or arc like situations, arc positions, point number 1 to point number 2, and entirely relates towards the theta and next phi values. The Cartesian specifically the particular movements. I think but point number 1 to point number 2 leads towards the rectangular or square representation, polynomials, exponentials, triangles, cycloids, etc. But in the joint space representations, the circles or else the arcs, different wavelength fluctuations, different sinusoidal waves generations, or counterpositions, which does not have a definite shapes, different circular shapes state. That is called contour positions. So these are the types of trajectory classifications. So path and timing law. So this is the path and timing law. After choosing a particular path, trajectory definition is completed by its choice of a timing law. If in the Cartesian system, P is equal to P of S, that leads to the displacement, where P is nothing but the path is directly depending upon the displacement. S is equal to S of T with respect to the time, right? And Q is equal to Q of lambda, that Q is the lambda is equal to the lambda with respect to T, nothing but the joint space and the joint curving positions or different wave representations leads towards the lambda. Here, Q represents the joint space. Naturally, based upon that, the timing law will be existing and it's a trace upon different constraints and its criteria depending upon the task and giving conditions, maintaining accelerations, and what is the velocity it has been imparted, and different types of loads that have been imposed on the particular object will be analyzed by this condition. Either in the Cartesian space, that is P dot of T leads towards the derivative of T with respect to the S. That is nothing but the displacement or displacement. Nothing but in the joint space, furtherly actions, the same time decomposition, P double dot of T relates towards P double dot with respect to the displacement plus d square P by ds square of S square. So double derivative. So incrementing from one section to another section. Hence, this trajectory planning, the basic differences between this Cartesian and joint trajectory. Planning in Cartesian space allows more direct visualization in the general path because the point-to-point alignment will be very much easy for joining. In any of the modes, either it may be a trapezium, rectangle, or also the square representation, straightforwardly from point to the point. And even the obstacle which will avoid the lack of wandering. More time need not to be specified. Planning in a joint space does not need online kinematic conversion. The major issues in the kinematic inversion, that is Q dot versus the Q double dot in the case of this joint, which is having the higher order derivatives, also needed that is Cartesian task specifications about geometrical path, that is x comma y comma z movements or particular values that is relates to the geometrical path, but also bounds on the associated timing and the redundant robots, the choice among the inversion solutions, offline positions and online positions, and even the loading conditions will be having a basic phenomena in the case of this joint trajectory when compared to the Cartesian trajectory. Comparing the relevant characteristics, computational efficiency and memory space, example, storing only the coefficients of polynomial functions. Those will be having betterly in the case of this, that is nothing but transverse motions that is trajectory motions related towards the geometrical constraints. That is also particularly in the case of this Cartesian coordinate systems. And next one is predictability and accuracy. And wandering out of the specified time points leads to an additional timing occupation by the end effector in the robot. There is a greater disadvantage in the case of the wavelength generations in the case of this jointed system. But whereas in the Cartesian system, that will avoiding. Going on to the flexibility, the primitive segments will be having allowed in the case of this Cartesian system transformations, and overplay situations also accelerate in the case of this both the systems. Overplay is happening in both the systems. Continuity is maintained, that is in space and or in time actions will be getting performed in the case of these Cartesian systems. That is in the joint system, it will be getting edge up motions and leads to an additional time also. Third derivative in time. So this is the symbolic representation that is being working in the three space, that is 3 degrees of freedom, X, Y, and Z. So robot is allowed to operate in its work volume in the 3 degrees of freedom. Sorry, three doubled. That is 6 degrees of freedom. Here that is positive X and negative X, positive Y and negative Y, positive Z and negative Z. So 6 degrees of freedom in the case of Cartesian space. So the nominal imposed conditions will be directed towards the Cartesian trajectory planning. As we have been discussed, that Q will be specified with respect to time basics, and this time will be depending upon the wave that is being generating in the case of this joint space. So the joint space is not having any specific points, and starting with respect to only the origin point by considering as a nominal, and particular radius will be maintained from that particular point onwards. So hence this lambda creates the wavelength that has been generated. So moving on to the boundary conditions, does not have a specified boundary conditions in the case of this joint space system. And this is the polynomial in space have been calculating the movements of the different links which are being existing as per the programming. The link 1 movement, link 2 movement, link 3 movement, and further actions. So 4 conditions will be maintained here for the polynomial when you have been considered. And that will be, this polynomials also will be basing upon the movements of the joints. Movements on the joints. So joints will be getting moved depending upon the elements expansion or contraction that is considered in the Cartesian system, or else towards the rotational or revolution motions that are being considered in the case of the joint space systems. So these are the conditions that are being obtained for calculating the conditions. So conditions of the movements taking place in the elements. So these are the first case, and these are the time relations which are doubly normalized, and these are the quantic polynomial conditions. So higher order polynomials are also possible in the case of this point to point motions, and these can be calculated with respect to the higher doubly normalized conditions also. And but in the case of the all other conditions, nothing but joint alignments, nth order polynomials that is having n minus 1 maximum and minimum points, which oscillates and interpolation movements also wandering towards the out of bounds leads to a lambda in a different counterpositions. So counterpositions, as we have been specified, that doesn't have any specified track for it. So this is the numerical examples for 9 degree or 10 from the point number 0, having the 4 different derivatives. and a condition that is having 14 different derivatives. The curvilinear position deviation having occurred in the case of ninth degree for 4 different derivatives, and next from 0. And 14 different derivatives, no overshoot or wandering has been occurred. Simultaneously, normalized first derivative velocity upon normalizing condition, we are getting the variable length deferred. Simultaneously, for peaking of the midpoint, we are getting the deviation result. So these are some of the examples related to the polynomial equations and the interpolation using the splines and its interpolations will be discussed in the next class. Thank you.